Gabriel Velasco from BSIT3A, and in today's video, I'm gonna discuss with you the routing algorithm and the two types of routing, which is static routing and dynamic routing. So without further ado, let's start this video.
First, let's define routing. Routing is the process of selecting a path across one or more networks in packet switching networks such as the Internet. Routing selects the paths for Internet Protocol packets to travel from their origin to their destination. An example of routing is when a router receives an IP packet. The router checks its routing table and compares all available paths to get the destination network of the received IP packet and selects the fastest path from all available paths. And now, let's define a routing algorithm. A routing algorithm is a procedure that lays down the route or path to transfer data packets from source to the destination. They help in directing internet traffic efficiently. Routing algorithm mathematically computes the best path that the packet can be routed through.
So guys, now that we are done discussing about routing algorithm, I hope now that you know how it works. So let's go to the two types of routing, which is the static routing and dynamic routing.
There are two types of routing, which are commonly called static routing and dynamic routing. First, let's define static routing. Static routing is a routing type in which a network administrator configures the routes in the routing table to be used by the router to send packets to a destination network. There are four types of static routes, namely standard static route, default static route, summary static route, and floating static route. First, let's define standard static route. This route includes a destination host address, its corresponding network mask, and the IP address of the next hop address. Here's an example figure of standard static route. Now let's move on to default static route. A default static route is used to send packets when an explicit route is not present in the routing table. By configuring a default static route, a router can match all packets to use this route. So here's an example figure of default static route. So now let's move on to summary route. This route reduces the number of routing table entries required for many static routes. A summary route can only be implemented on contiguous routes that use the same exit interface or next hop address. And here is an example figure of summary route. So now let's move on to the last type of static route, which is the floating static route. A floating static route is a backup route to any static route or dynamically learned route. This route is used only when the primary route fails or is unavailable. And here is an example figure of a floating static route. So guys, what does a static route do? A static route can be used to reduce the number of routes advertised by a router, create a backup route if the primary route fails, to connect a device to a specific network, and finally, to connect a stub router or a stub network. And now, let's talk about the advantages of static routing. The first advantage is that it provides easy routing stable maintenance in networks. Second, static routing consumes less bandwidth when compared to dynamic routing, as no CPU cycles are used in route calculation and communication. The third and the final advantage of static routing is that because static routes do not advertise their route over the network, it results in better network security. And that's it for its advantages. So, if there are advantages of a static routing, there are also limitations on the static routing. And here are some of those limitations. First, in large networks, configuring and adding a static route to the routing table is very difficult. Second, configuring static routes requires background knowledge of the network topology by the network administrator. And third and final limitation of a static routing is that static route is error prone. And that's it for its limitations. And now guys, after discussing the static routing, let's move on to the dynamic routing. What is a dynamic routing? Dynamic routing is sometimes called adaptive routing. It is more complex than static routing because it creates more possible routes to send packets across a network. Dynamic routes are typically used in larger, fluid networks where static routes would be cumbersome to maintain and frequently reconfigure. Because dynamic routing is more complicated, it consumes more bandwidth than static routing. Dynamic routing also uses algorithms to compute multiple possible routes and determine the best path for traffic to travel through the network. It uses two types of complex algorithm, which are distance vector protocols and link state protocols. Both distance vector and link state protocols create a routing table within the router that includes an entry for each possible destination of a network, group of networks, or specific subnet. Each entry specifies which network connection to use to send out a received packet. Here are some types of dynamic routing. First is the distance vector protocols. When using a distance vector protocol, such as Routing Information Protocol or RIP, or Interior Gateway Routing Protocol or IGRP, each routing table entry specifies the number of hops to each destination. Routers using distance vector protocols periodically exchange their routing tables with neighboring routers. Distance vector protocols have their advantages and disadvantages. Routers that use distance vector protocols periodically send out their entire routing tables, which produces a significant load when used in a large network and could create a security risk if the network became compromised. Because distance vector protocols determine routes based on hop count, they can choose a slow link over a high data rate link when the hop count is lower. Now, let's talk about link state protocols, such as Open Shortest Path First or OSPF, and Intermediate System to Intermediate System or ISRS. These determine routes by exchanging a link state packet or LSP with each neighboring router. Each router constructs an LSP that contains its pre-configured identifier along with information about connected networks and subnets. The router then sends the LSP to nearby routers. Received LSPs contain additional information about paths to other networks and link data rates. Routers combine this information with previously known information and store it in their routing tables. Like distance vector protocols, link state protocols have their benefits and drawbacks. One benefit of link state protocols is they send out updates only when there is a change in the network, in contrast to the constant load distance vector protocols placed on the network. And now, let's talk about the advantages of dynamic routing. First, it is straightforward to configure. Second, it adapts to network topology changes. Third, it is suitable in a network where many routers are used. Fourth, and the last advantage is that configuring dynamic routing does not require detailed knowledge of the network. And these are the disadvantages of dynamic routing. First, dynamic routing consumes many network resources when compared to static routing. Second, this is because dynamic routing broadcasts network information, which amounts to a huge security risk as an attacker can learn about the whole network, especially during recon attacks. And third, and the final disadvantage is that it can be complex to install.
And now guys, after discussing those two types of routing, now let's try to differentiate them. So guys, here are the main difference of the two types of routing.
So, for our final topic in today's video, let's talk about the difference between static routing and dynamic routing. First, let's talk about the path selection. When it comes to path selection, static routing uses a single pre-configured route to send traffic to its destination, while dynamic routing provides multiple available routes to the destination.
Second,
when it comes to ability to update routes. Network administrators must manually reconfigure static routes in order to adjust routes, while dynamic routing uses algorithms to automatically update the preferred route change. Third is that when it comes to routing tables, static routing has a smaller routing table with only one entry for each destination, while dynamic routing requires routers to send out their entire routing tables to identify route availability. Fourth is when it comes to the use of protocols and algorithms. Static routing doesn't use protocols or complex routing algorithms, while dynamic routing uses distance vector protocols such as RIP and IGRP, and link state protocols such as OSPF and ISIS to adjust routes. Let's talk about security. Static routing is more secure because it doesn't share routes across the entire network, while dynamic routing creates more security risk because it shares completely routing tables across the network.
So guys, I hope you learned something from this video. Thank you for watching and good day.